All right, so let's just quickly review what we talked about before we left for lunch. Here we have a table showing the rate of change for each set of values. And what we learned was that these little symbols right here, the little triangles, is called the change in Y over the change in X. So how we figured that out was we looked at rows 1 and 2, and we wanted to know we're going from 5 to 10. So that's a +5, 10 to 15, that's a +5, and 15 to 20, that is also a +5. Then you look at the change in X, we're going to a +1, +1, and then a +1. So rows 1 and 2 is the change in Y is 5 and the change in X is 1. Now, here's what you need to understand. So you may want to write this down. The rate of change is 5 over 1, or you can simplify that as 5. That is the rate of change. Slope is the rate of change. And there is an equation that you will need to know, which is Y equals mx. Now, this m here is your slope. M represents slope. It's a special variable that is assigned to slope. So m equals the slope. So if I said to you, what is the equation for this table? What would you say? So I'll say it again. What would be the equation for this table? Well, I don't need to put in anything for the y, and I'll show you why. Y equals, do we know what m is? Yes, what did we say it was? It was 5. Or it's also 5 over 1. So you could say y equals 5 over 1 x, or simplify it to y equals 5x. Okay, the 5 represents what? The slope of the line. So that is the rate of change equation that you will need to know. I'll say it again. Y equals mx. The m is your slope. What was the slope or the rate of change for this table? It was 5 over 1, which simplifies to 5. So to write the equation, it would be y equals 5x, and that's all you need to write. Now, if I go back to something else here, we had 5 over 2. 5 over 2. Well, you're going to do the exact same thing for 5 over 2 as well. The equation is y equals mx. What's the slope or the rate of change? It was 5 over 2. So you would write the same thing. Y equals 5 over 2 x. Same thing. So you're plugging in the rate of change, whatever that is your m, that is your slope, into the equation y equals mx. You don't need to worry about the y and the x at this point, but that's how you would write it. Are there any questions before I go on? Okay, here is another example. All right, find each rate of change. Now, this one is a little different. So find the rate of change for each set of values. Let's look at rows 1 and 2. I'm going from 48 to 36. Am I going up or down? Show me with your thumbs up for going up, thumbs down for going down. All right, I'm going down. So 48 to 36, the difference is a -12, right? Or a -12. 36 to 24 is also a -12 or a -12. 24 to 12, I'm going down 12. If I look at my X values, 1 to 3, that's a +2. 3 to 5, that's a +2. 5 to 7 is a +2. So if you look at rows 1 and 2, my change in Y is a -12 or a -12, and my change in X is a +2, a +2. Anybody have a question? Just unmute yourself.
Miss Zell,
Yes.
why would you put a negative in front of the 12?
Because it's not a +12. We're not adding 12 every time. We're taking away 12. It's going down 12. Because remember in slides before, you're doing a +5. Well, we could write a +5 here, but we don't because it's understood, right? All of these have been adding, right? We haven't done one where we're subtracting or the difference is 12. So if I just left it at 12, that means that it's increasing by 12 every time, but it's not. It's going down 12. So you need to put a -12 there. That's why. Good question. All right, and then rows 2 and 3. So row 2 to 3, 36 to 24, I'm going down 12. My X, I'm adding 2. All right, let's look at rows 3 and 4. Again, -12 and a +2, and I'll just put a +2. Did you get the same rate of change each time? Yes, we did. Is this a linear function? All right, this is a very important question. Is this a linear function? Let's go back to our definition. Okay, so look up at the top, the constant rate of change. If the value of the change, that little triangle stands for the change. So if the value of the change in Y divided by the change in X is the same every time, the function has a constant rate of change. So if the rate is a constant rate of change and it's a constant every single time, then it is a linear function right here. Functions with a constant rate of change, meaning that it's the same every time, it's going to be a linear function. And a linear function, remember, has the word line in it. It's going to form a line. And we'll be able to show our slope. Okay, so to answer that question, is it a linear function? Yes, because it is a constant rate of change. So whenever it is a constant rate of change, it is a linear function. So let's talk about that equation, the rate of change equation or slope. So if I had to write the y equals mx, and m is our slope, okay? Our slope is y equals -12 over 2x. Well, that looks kind of funny, right? You always want to reduce it to lowest terms. If you just left it at -12 over 2, it would be technically correct, but you always want to put it in simplest form. So simplest form would look like this. -12 divided by 2 is a -6. So y equals -6x. Now, what you're going to learn, slope equals the rise going up or down or the run. Now, I don't have a fraction under a -6. Well, I could put a 1 under that, right? That would be my run. So -6 is also -6 over 1, right? -6 over 1. But this is in simplest form. They mean the exact same thing. Any questions before I move on? No questions? Okay, go ahead and fill in this chart for me. Says, in this case, you are adding 1. So if you didn't put a +1 and it was subtracting 1, you would need to put a -1. That makes a huge difference. But in this case, you said it was 1 over 2. So the change in y is a +1 over the +2. Let's have Ben. Go ahead and tell me row 2.
Row 2 and 3.
Yes.
Row 2 and 3 is 1 and 2.
Yep. So +1 and a +2. So that is the change in 1 over change in 2. Okay. And row 3, let's go with Malia. What is the change in row 3 and 4? What are you doing from 3 to 4?
+1.
And then, oh, look at X. What's the change in X?
+4.
All right. Is this a constant function? Who can explain this one? Somebody?
It's not a constant function
Why?
because all the y values are constant, but all the x values are not constant numbers.
Yeah, it is not a constant function because the change in y over the change in x is not a constant rate of change, right? Because the rate of change changes. This is the same, right? But from here to here, not the same. Make sense? So would it be a linear function? No, because of this, right? It's not going to be a constant rate. It has to be the same in order for it to be a constant rate of change or a linear function. So that applies to both. Any questions so far?
Ms. Zell,
Yes.
if you have a constant function, if it's not a constant function, does that mean it's not going to be a linear function?
Correct. 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 All right, so let's go ahead and look at the y equals mx. Let me get my videos here. So in Schoology, we have 3 videos. What is slope, rate of change, and then we have our third one. So what we're gonna do is watch our videos so that we understand what we just went over. So one of the things that I want to review with you is this particular slide right here, because on your exit ticket, there is a question on there that will ask you to answer all that apply. For example, what is the rate of change? What's the proportional relationship? And notice that, as you can see, what I've written in red at the top on the right and the top in green. Okay, would they both be considered the same thing
Is negative 12 over 2 the same thing as a negative 6 over 1? Show me with your thumbs up or thumbs down. Is negative 12 over 2 the same thing as negative 6 over 1? Yes or no? Yes, very good. It's reduced. They mean the same thing. It's also the same thing as y equals negative 12 over 2x is also the same thing as y equals negative 6x. It's just been reduced. So do you see the difference there? So when you're doing your exit ticket and it asks for more than one answer, you may want to go back to this slide here because you can display the answer in more than one way. And also the other thing that you need to remember is the formula for what we talked about today. So the formula you do need to know is y equals mx, and the m is the slope or the rate of change, and that's what this is up here at the top. Okay, so those are the two things that you need to know for today. So before you do your exit ticket, I want you to watch the 3 videos so that you have a better understanding of rate of change and the slope. We're going to dive deeper into slope tomorrow. You don't really need to know the slope as far as graphing it yet. We're going to do all of that tomorrow. So watch the 3 videos. I do have an IXL for you to do, which is 7th grade. 7th grade K1, and it's find the constant of proportionality from a table. That's exactly what we've been doing. And then of course, complete today's exit ticket. So watch the videos first, then you could try your IXL, and in your homework folder, I try to get between an 80 and a 90 of a SMART score. If it's pretty easy for you, then go for a 90. If you're really struggling, it takes you a while, then you can stop at 80. But challenge yourself. If you can get to 90 pretty easily, then get to 90. And as always, if you have any questions for me, please send me an email if you get stuck or you you don't understand something. And then of course, at last, complete your exit ticket. But be real careful on your exit ticket, okay? Because some answers you could have more than one answer.